Hi there, thank you for watching this demonstration video on the jet-borne visual circuit with vertical takeoff and vertical landing in the AV-8B Harrier. So in this video I'm going to cover off how to set up the cockpit instruments to give you the best possible chance of flying the circuit accurately and safely. And then I'm going to go through how to perform the pre-takeoff data assignment, the one-finger checks, and then we're going to go through the takeoff, transition to wing-borne flight, the circuit itself, the transition from wing-borne to jet-borne flight, and then of course the landing. So starting with the cockpit setup, here's a few tips of how I like to set things up. Everyone's a little bit different, so it's entirely up to you how you set them up, but here's my recommendations. So the first thing that I would recommend doing is just raising your seat slightly. I find that this really helps with a bit of forward visibility over the nose. You can use the little bulge on the nose there where the forward-looking infrared sensor is to help you line yourself up with things. That's especially useful for carrier ops. And you also get a bit of a better visibility out the side, and you can lean over a bit further, especially if you're in VR. Okay, the next thing I do is set up my moving maps. So I like to put it into a red mode just because it's easier to read in VR. Obviously not entirely realistic. I like to turn down the gain so that I've got a nice solid outline of the shapes, but the actual symbology is nice and clear. I like to bring the scale down to 5, and then again if we hit map M on the left and then hit zoom at the bottom, second one along, there we go, we can just bring that down even further. Of course this is only really relevant for the visual circuit, and really if you're doing other things, you know, you're not doing VSTOL practice or carrier qualifications, whatever the case may be, you don't necessarily need to do that. Okay, and then next we need to put in our course line, which for vertical takeoff and landing is always going to be exactly the same as the headwind, because you want to land in wind, but like a helicopter. So 338 degrees it should be. Yeah, and we can see here that that's roughly aligned with the aircraft, which is exactly as it should be. And the final thing is just to set the altimeter to the field pressure. So basically zero it. So right now you can see it's on 100 feet. Just click it down until it reads 0. Be careful not to overclick it. So right now you can see that from 6.9 and 6.8 it's on the exact number that we need. If I bring it down even further, it still reads 0, so you'll get a false reading. What you'll actually find is the altimeter won't come alive till whatever altitude it is that you set it to. So let's say you bring it down 3 clicks, and that's, I believe, 30 feet for every 0.01 inch of mercury. So you would need to get to 30 feet before it came alive. Okay, let's go into the pre-takeoff data assignment. So we're just going to come over the left MPCD here, because then we've got the ODU directly above it. Go on the VRES page, and straight away we're going to put in the basic aircraft weight, which is, sorry, the operating weight, which is 16,475 pounds. And of course that's going to overwrite the basic aircraft weight. And then your BDI, which is going to be 16 in this case. And obviously that's more relevant for fuel efficiency, the BDI, but it is a good practice to keep. Then we're going to go in the stow page. We're going to put in the field data, so runway distance really doesn't matter in this case. Runway headings 338 degrees, and then the ground wind is 338 at 009. Is that correct? Yes, it is. And then, of course, outside air temperature is going to be 29. And the field elevation, so this is an important one. So the field elevation, the computer will calculate figures based upon your current altimeter setting, and it will then assume that the field elevation that it pulls from the INS library for wherever the relevant waypoint or wherever you currently are is correct versus the INS library. Now, if you're doing an actual operation, you'll always operate on QNH in and out of a fob. For training purposes, because we scrutinize the circuit so closely to make sure that you've got full control of the aircraft in all the different configurations of VSTOL operations, we recommend that you zero the altimeter. Now, the problem with that is if the altimeter right now is reading 0 and I'm actually 100 feet above sea level, and then the field elevation is also reading 100, it's going to assume that I'm at 200 feet, and it's going to give me reduced engine performance information because the air will be less dense. So we need to set this to 0. Okay, so that's pre-takeoff data assignment, field elevation done. So now we just need to go over to our vertical takeoff box, because remember the values for the vertical takeoff will always be more restrictive than the values for the vertical landing. So if you can perform a vertical takeoff, you can perform a vertical landing. Okay, and we can see here that with wet setting, we can take 4,296 pounds of fuel plus water, minus your 500, it's going to take that down to 3,896. And right now we're at 3,700 pounds. It's perfect. And we are going to use water because it is above 20 degrees C, and that's just my personal rule of thumb. If it's above 20 degrees C, or if I know I'm particularly heavy or at a particularly high elevation above sea level, I'll always go with water on. Okay, so we'll bring our EHSD back up, and we'll get ready to perform the one-finger checks. We'll just open the hood up on the right-hand page here, so that we've got something in case we look into the sun, and I'll make sure our hood's turned up. Okay, one-finger checks for the vertical takeoff. Coming down the bottom left, store stops in the clear. Nozzles are going to come back to 82. I'm going to look over the hood for that. Throttle's closed, coming forward. Make sure our lights are on. Nose wheel steering is on for the vertical takeoff. Flaps are in the auto position. Combat water always comes on for our one-finger checks. And then we're going to put the takeoff landing water in the takeoff position. I'm not going to go through the two-finger checks just for the expedience of time in this video. But at this point you should, well, in this case it would be 5-finger checks, but at this point you should be fully adept with your 5-finger checks. Okay, so a quick verbal walkthrough of what we're going to do. I'm going to perform the vertical takeoff at 50 feet. I'm going to start the transition to wing-borne flight. I'm going to bring my nozzles forward no further than 25 degrees using the capture attitude technique. Once I arrive at 25 degrees, I'm going to bring the power back, and I'm going to perform my standard pre-takeoff checks, which is to clear the stow stop, check the flaps, which in this case we're going to leave in VSTOL, and check the nozzles as well and the water into the off position. So stow stop, nozzles, water, flaps, then water. After we've done that, I'm going to level out at 1,000 feet, get the aircraft trimmed for 10 units of AOA in the straight and level. I'm going to start my turn. I'm going to aim to be between 0.8 and 0.8 and 1.0 on the delta distance when I come on the downwind using a left-handed traffic pattern at 1,000 feet. Before reaching the abeam point, I'm going to bring the nozzles back to 60 degrees again. At the abeam point, I'm going to start timing for 15 seconds in this instance because we've got a headwind of less than 10 knots. Now, the way I do my timing for the headwind is I'll look at the time there, and however many seconds it is at that time, I'll add 15 and I'll say up to whatever. So here I would say up to 15, and I will go with that. After the 15 seconds, we'll adjust the power for rate of descent and the stick for AOA, and we'll trim that, and we're going to look for roughly 500 feet per minute descent rate during the first half of the turn. We're looking to be between 500 and 600 feet by the halfway point known as the 90, and then by the time we roll out the key, we're looking to be at 0.6 nautical miles DME from the waypoint represented in the hood, and roughly 325 feet plus or minus about 10 or 15 feet. At that point, I'm going to consider myself to be at the key, and I'm going to bring the nozzles back to 82 degrees, and I'm then going to transition the aircraft into jet-borne flight. From that point onward, I'm going to ballpark the aircraft over the general landing area. So I've got these vehicles here as a reference point, that windsock, this lovely big bit of tarmac here, and I'm going to look to be at about 150 feet over the point. I'm then going to descend from 150 feet down to 50 feet, looking to position myself directly above this point here. Once I'm directly above the point, I'm then going to do a standard vertical landing onto the point. Okay, so without any further ado, toe brakes on, park and brake off, clear the master caution, check with its forwards. For the skid, that's fine, we're going to leave the nose wheel steering on for vertical takeoff. Holding the toe brakes. Sanity check, make sure everything is the way it should be. And gradually increase the power. Okay, just took a little break there so I could get that indicator up here. Continue and increase the power. Okay, let the aircraft come up. 10, 20, 30, 40, 50. Capture attitude technique. Stick and nozzles. Look at that velocity vector going for 25. And retard the power. Look down, still stops clear, nozzles down, and water off. And we're going to continue to let the aircraft climb. Now, it's really important because you're nice and light and you're only doing a training circuit. Don't let the aircraft climb away from you. Take your time. So here we can see I've got it under control. There's about a thumb width between the witch's hat and the velocity vector. Okay, I'm going to rest that rate of descent there. And I'm going to bring the power back. And then bring the power up to catch it. And just trim that there. So 9.5 units, 10 units, there we go, trimmed on the colloquially known upwind. Alright, now we're going to start our turn. Good look out. Top of that, start our turn. Adding some power in the turn because we're still relying quite heavily on the engine for lift. Okay, looking down 0.0, that's fine. It's fine. 0.1, got a little bit of rudder in there. 0.2. And we're about halfway through the turn. 0.3, 0.4, halfway through the turn. Perfect. Let's keep it coming. Tiny bit high. And we're looking into the turn still. 0.8. And we just need to tighten up that turn there, otherwise we're going to miss our point. 1.1, so I'm a little bit wide. 1.2. Officially on the downwind, pointing it in a bit to get us back on that delta distance, adjusting for AOA. And now nozzles back to 60, expect the balloon, bring the nose down to anticipate for it to leave the throttle where it is. Okay. 1.1, so we'll start to ease off that turn. We're a little bit low, we're within 50 feet, so that's okay. There we go, 1.0 nautical miles delta distance, turning back onto the reciprocal. We're now officially downwind. And this is the point at which we'd say 464, abeam, wet, 3.2. And we're going to time for 15, so that's up to 40. There's 40, drop the power, start the turn, bit of rudder, looking for between 10 and 12 units of AOA at about 500 feet per minute descent rate. What's more important than that is we're looking to be at about 600 to 500 feet at the 90. And water's on. And we're coming up on the 90 and we're a little bit high. So we just bring the power back there, just the rate of descent. AOA got a little low as well as we ballooned. And we're squaring off that turn there because we're a little bit slower than before. Okay, there's 600 feet. And we're aiming for that centermost point there. 500 feet, we're at about 10 or 12 units of AOA here. Just on the id limit. Okay, misjudged that turn, I turned late. Lots of rudder to get us through, and we're quite high, 400 feet.
Altitude.
So maintain that rate of descent.
Altitude.
0.6 miles, bring the nozzles back.
Altitude.
We're at the key at 320 feet. Just managed to recover it, watching the AOA. Clear the warning. And we're looking for 120 feet. Letting it descend nicely. Same skills that you need to have for maritime operations. 12 units of airway still, just on the cusp of what's acceptable. As 120 feet, bringing the power up, bringing the nose up to arrest our forward movement. Looking at the S there for our ground speed. So we're at 20 knots ground speed, 16, 15, and we are ballparked. 110 feet, a little bit low. Bring the nose down, stop us from going backwards. We're going to descend down to 50 feet now. We can ignore the airway now. Let ourselves descend down to 50 feet. And we're trimming the entire way down. Okay. Bring ourselves over the landing spot. We'll get that nose down a little bit. Come on, over to the right. There we go. A little bit of corrective action. And let's commit. Power back. Let the nose come up to the witch's hat on the horizon, and we're looking down and to the right. Idle. Brakes.
Water.
Okay, so I appreciate there were a few small mistakes made there. You will always make mistakes. Do not stress about them. From every pass, you need to just recognize where you went right, where you went wrong, and focus on one thing at a time. You will then become it will become second nature for you to be able to do those individual components, and you'll become really good at unitasking. So switching from one task to the next task and back and forth. The more you practice that and the more you become familiar with each individual area and focus on your weaknesses, the better you'll become. And you will always make mistakes, so don't get annoyed about them. Don't try to be 100% perfect all the time. Just try and be better than the last time, and you will improve. So the key points to note there where I made small mistakes were I misjudged the initial turn, sorry, not the initial turn, the turn from the upwind to the downwind. So that's quite an easy one. It's quite difficult to judge that, and it normally takes a couple of passes before you get it right. And again, turning from the beam point, the final point, right the way around to the key, it can be easy to think that you're turning tighter than you are and widen it out, and then find yourself in a situation like I did, where actually you've widened out too much. So those are things to be mindful for. And then, of course, the rate of descent all the way through. So you could see I had a 500 feet per minute rate of descent almost the entire way from the final area right the way around to the key. And I literally just made it to the key, 0.6 miles, 320 feet, as I hit 0.6 and brought the nozzles back. So realistically, the first half of the turn from the 180 to the 90, that should be a steeper turn, so about a 6-degree glide slope, so 500 to 600 feet per minute. And then the second half of the turn should be a 3-degree glide slope, so usually about 300 to 200 feet per minute. And that's just to make the transition from descending and being semi-jet borne to being completely jet borne and descending less as you want to then ballpark the jet a little bit easier. And then as we came in over the top and we ballparked and I tried to crack the position, I got myself a little bit disorientated because I was looking down too much. Always use the features in your 2 o'clock and 10 o'clock positions, so in this case that building and these two vehicles that are conveniently lined up for exactly this purpose, for the training purpose. And I spent a little bit too long in the hover. You've obviously got your 60 seconds delivery, where from the moment you transition at the key to fully jet-borne flight, you want to be hovering for no more than 60 seconds before you start bringing the power back to touchdown. I hope that you found this video useful. I know I've spoken very fast in it. If you have any questions, please do feel free to get in touch. Thank you for watching.